My name's Tony Alcacer, and I'm one of the flight safety reviewers for Spaceport America's Cup. And today I'm going to go over the things that every rocket that flies at Spaceport America's Cup has to go through before it's allowed to fly. And it's very similar to the process at NASA's Student Launch Initiative, too. So this rocket here is similar to one that would be flying in the 10K class, 6-inch diameter, weighs about 45 pounds, flies on a 98mm 3-grain M motor. And we're going to go over the things that I check out. So one of the first things I do is general impression of the rocket. What's the workmanship like on the outside? It's going to translate over to the inside. Are the fins tall enough? Are they big enough? Are they good design for the anticipated loads or the speed of the rocket and the altitude that it's going to? And I like to start at the nose cone first. And if this rocket had an aluminum nose cone to it, I'd want to make sure that that was nice and tight. They have a tendency to heat up in flight, become loose, and then whatever air that's Mach 1, 2, or 3 going into that nose cone is usually not a good thing for that flight. So if it's a student SRAD built nose cone, rockets, and fins, I'm going to pay a little bit more attention to those aspects just by squeezing on them, asking how many layers they used, what epoxy system did they use, and go from there. So this one is pretty straightforward. It's a commercial nose cone from a long time ago. The body tubes have a single layer of fiberglass over phenolic tubes. I'm looking at shear pins that holds the rocket together. In this case, there's 3 440 nylon screws in each section that holds the rocket together so that it doesn't drag separate. I'm going to make sure that there's holes in each bay to vent the pressure so that the trapped air in there as the rocket goes up doesn't get bigger and pops the nose cone or the fin cans off. So each section has to have a vent hole. There's one here and there's one right here. The other thing I want to look at is the holes in the electronics bay for either switches or for air holes for the electronics. The other thing I'm looking at are the fins. So are the fins big enough for the job at hand? So when we talk about rockets and stuff, when we talk about one caliber, a caliber is the diameter of the rocket. So in this case here, it's a 6-inch rocket, so I want to have at least one caliber semi-span on the fins. And in this case here, I have 6.5 inches, so I have slightly more than one caliber of semi-span. The other thing I want to check is how strong the fins are. I should not be able to move these fins very much at all. That these fins are .10 6061 aluminum fins held on with 8 screws. If this was your rocket and you could do this to the fins, we would not let you fly. You would have to repair or strengthen those fins. So these are not very good. Just because you have the right material for your fins doesn't mean it's going to work, that you have to have them attached strong too. That this is solid 1/2 inch or 3/4 inch aluminum fins that came off because they were held on with 30 little tiny screws and stuff. So just because you have strong material doesn't mean it's going to hold together. The fins are a system. The shape of the fin matters. They have a narrow root and a long semi-span. They're more apt to flutter. If they're not attached very well, they're going to break off. And so it's a whole system on the fins. So the other thing I'm going to look at on the outside of the rocket is if there's any markings on here, what those markings mean, and if they're correct. And then the other thing is the rail guides. Your rocket will have 15 rail guides. And one thing that we're going to do is we're going to make sure that a rail will pass over these. They're held on with number 10 machine screws, and we don't want to see little wood screws going through the body. We don't want to see the body tubes threaded. We want to see substantial mountings for these. Your rocket's literally going to be hanging by those 2 or 3 points. So yes, the rail guide fits on there. Is it good enough to hold that rocket being wiggled and launched by those small points? So up to this point, we've been going on HeroX, looking at your updates, exchanging emails with you, videos, questions, drawings, and stuff. And so at Spaceport, this will be our first time to actually touch and feel the rocket and see if we've been talking about the same thing and it's strong enough and stuff. So from this point, we're going to go ahead and open up the rocket, and we're going to pop off the shear pins that are in here, make it easier for me. So this is where my rocket would come apart at apogee. So the coupler, the length of the coupler we're looking for is we want it to be 1 caliber, in this case 6 inches long, that goes up into the rest of the body tube. Anything shorter and it starts letting it wiggle and it's not a very good fit. So we want 1 caliber couplers up inside the body tube. One thing that's important too, the day that you bring your rockets to the flight safety reviews, is do not bring any energetics into the convention center. No propellant, no charges, no E-matches, and no igniters. So this end of my shock cord is anchored up inside the rocket via a muffler clamp or a U-bolt. This is Nomex material that's protecting my parachute and the shock cord. And I have about 35 feet of shock cord in here. I have a big 60-inch military surplus drogue parachute. The black electrical tape are called break points, and I'll show you what those are. So to help dissipate some of the energy and stuff, I'm going to take and fold this 1-inch tubular nylon. I'm going to take some black electrical tape, and I'm putting it on here as strong as I can, as tight as I can. About 4 or 5 layers on this one. We'll do another one over here. And I'm going to put 2 on this one. Again, as tight as I can. 3, 4, 5. Two, 3, 4, 5. So when my charges go off, if I have extra kinetic energy, some of it gets dissipated there and there. So if I have 4 or 5 of those, I can dissipate a few hundred pounds of kinetic energy to save my anchor points, save my shroud lines, and ease the deployment at apogee. So we're going to look at the anchor points. We can't really see this one here, but I have one that's made up. And I have a forged eye bolt, 1-inch tubular nylon, which is about 4,000 pounds of breaking strength. I have a piece of Kevlar here that's zip tied, and what this does is it keeps this eye bolt from being able to unscrew itself. It happens. You can use Loctite, you can use pins, you can use jam nuts. This is a very simple thing to do. It's very light and it's very foolproof. Another thing that we need to do with nylon is protect it. On this side here, I have the orange nylon inside blue nylon and using that as a disposable layer. If I wanted to, I could use duct tape. Put on the shock cord for as long as you think you need it to protect that shock cord from the ejection charges. At Spaceport, we're going to look at every inch of the shock cords, making sure there's no big bad burn marks. From the ground test, I have some very minor ones, and so this shock cord's okay to go for now. We'll go up here, remove the pins. No wiggle there, nice and snug. This is where my main parachute is. And in this case here, I have 27 feet of 1-inch tubular nylon. I have 3 60-inch chutes. On here. Nomex material, not really a deployment bag. It's actually the legs from the Nomex pair of pants that everything fits into. You can see what the ejection charges do. It takes the dye out of it, but it protects all the stuff inside the Nomex. Again, the blue is secondary, protecting it down where the charges are. We can talk about charges here in a minute. We're going to talk about quick links and eye bolts and stuff. So, in the rules it says that you have to use forged eye bolts or eye nuts, and I'll take pictures of these and put them at the bottom, or welded open bolts. Forged is much stronger, costs more. And for quick links, I was talking about how my 1-inch tubular nylon is 4,000 pounds breaking strength and has some stretch built into it. I would need 2.5 quick links this size to accommodate the right pressure, breaking strength. And so I just do a lot of loop-to-loop or not-to-loop connections. That way I don't have to have a lot of quick links. And there's actually a video recently of a rocket going up, and it has the quick link riding on the edge of the tube like this, and in about 2 minutes the quick link opens and you can see the fin can of the rocket fall away. So whenever you're using hardware like this, you want to make sure you wrench tighten them. and stuff. I use a lot of eye bolts, or eye nuts, sorry about that, and not so much the eye bolts. We talk about ejection charges. For this rocket here, I use at Apogee 3/8 vinyl tube charges, and they're kind of like a gun in that they're long and skinny. One end of the tube is blocked off right here. There's a little bit of dog barf cushioning. This case, 2 3/4 is black powder, and the E-match actually sits on top of the black powder. And the thought process was that when the E-match burns, all this powder underneath has to get past that flame front and be consumed, unlike using a PVC cap where we fill it with black powder and usually put the E-match on the bottom of the pile. When we set that E-match off, and this is taped closed or epoxy closed, and that E-match goes off, it blows everything up in a fountain of unburned black powder. Some of that black powder is going to burn, some of it's going to fall into the shot cord and everything and break the pyrotechnic chain, and so it's not 100% efficient. Helping it would be just simply taking that E-match and moving it from the bottom to the top of the pile. But going to a longer, skinnier ejection charge holder is more efficient and works better, in my opinion. I talked about Kevlar cord instead of tubular nylon. This size here is probably 1,200 pound test. There's zero stretch to it. This would not be an appropriate size for this rocket. That would be like a 54 millimeter rocket. I think this is 3/8, might be about 2,000 pounds breaking strength. It needs to be protected too. Again, no stretch to it whatsoever. And then this, I believe, is 1/2 inch and might be 3,500 pound breaking strength. It's stronger for size and weight, but there's no stretch to it, and you still have to protect it. You can still do the break point with the electrical tape to take some of that kinetic energy out of your Apogee event. So, I'm not saying Kevlar is bad, I just don't use it very much. We're going to talk about payloads and electronics here now. The payloads that I like are the ones that stay in the rocket, don't move around, don't change the center of pressure or center of gravity. They have nothing to do with the flight of the rocket, and those are the ones rocket guys like. The ones we don't like are the ones that have to get deployed and could cause a problem tangling with the rocket's own recovery system. A good way to avoid that is have your payload go out with the nose cone and its own chute. That gives it a clean shot for the rocket's drogue to be on its own. So you have the nose cone and your project on a chute, and then you have the fin can, the body of the rocket coming down on its drogue. We don't want any pyrotechnics or explosives type of things in there. If your project's pretty small, a 90 decibel warning wobble sound is pretty nice to have for us to at least look to see which direction it might be coming down in. But all that we can talk about leading up to that event. This rocket's electronics are in a side hatch here. I'm going to take this cover off, that access the switches and our electronics. As you can imagine, this is just a regular rocket. There's tons of room in here, so the electronics are very simple. They slide out. On one side we have an arts, a screw switch, and a battery. It's fairly easy to see where the battery connections go, the screw connections go. Fairly easy to get to them. Feeding the igniters, or not igniters, the deployment charges in from the outside. We'll do that here in a minute. The other side, stratologger, screw switch by itself, battery source, very easy. When you put payloads in there, GPS and other electronics, it's pretty hard for us to follow, make sure, but the whole thing is that an on-off switch that is going to work. I make these 3D printed with a military thing inside. They've been up to 85 Gs. I've never had one fail. When we hook them together, we're going to tighten them down, and each time we're going to twist and then tug. Twist it, screw it closed, tug. Make sure that we are under the pad, and just for fun, any of the things that are under here, we're going to pull on them too. Same thing as we put our E-matches on, we're going to tug on these, and we're going to also tug on the ones that are pre-existing to make sure that they didn't come loose. So electronics are pretty simple. I have the vinyl charges for apogee, which are down here. There's bolts in here that have 1/4 nuts on them, or couplers that fit on these, so they just sit on there. This is going to be hard to do. Here we go. And then I'm going to seal those ports. I can use regular clay. I can use this stuff called Duct Seal. It's a little bit stickier. I can use this other stuff that's stretchy, like window or photo hanging stuff, picture hanging stuff on the wall. Or I can use hot glue, but we do want to seal those openings to keep any of the black powder charges to getting into our electronics. We can put twists in the wire, we can put zip ties on the wires to do strain relief so that it's not pulling directly on the board. If you're the electronics guy, the best thing to do is have printed out copies of the instructions for the manuals you have. That when you get on the ladder and you turn that first altimeter on, what are you listening for? Do you want to hear 3 fast beeps and it beeps 7 slow beeps? You want to be able to troubleshoot that. It's easier to do it with the instruction manual with you, and but going up that ladder, knowing what you expect to hear first is a big thing, and knowing how to troubleshoot it when you're on the ladder is another good thing too. So this is just a real rough, fast, talked fast, hot day, what to expect for the range safety review once you get to Spaceport America. This video will hopefully generate questions so that you can go into our range safety inspection live talk and have a bunch of questions, or hopefully this answered some of your questions too. I'm sorry if I got tongue twisted. I haven't done a video in a while. Hopefully you did learn something. Now I want to say you do not have to use things like this, but nylon is a good choice. 4,000 pounds, fairly cheap for this class of rocket. Nothing against Kevlar. You don't have to use aluminum. This is just what this rocket is and the things that we're looking for. The one last thing that I did is that my GPS is actually in the nose here. There's 2 screws. This tip comes off and my nose. My GPS is here in a nice non-carbon fiber bay. So once we get done with your safety review, and we usually do find stuff wrong, you have the opportunity to correct them. It may be a matter of putting some fender washers on a better eye bolt, replacing your shock cord. There'll be vendors there, or doing something. The harder things are to fix fins that aren't strong enough. We've had about a 50-50% of fixing those on site. Home Depot and a lot of JB Weld and some fiberglass is usually what it takes to fix those. But anyway, you'll end up with a copy of this. Each of your items that need to be corrected will be listed. You do not have to take this back to the same person that wrote it up. Any of the flight safety review people can check it off. Once you get it corrected and you get an approval to fly, you'll be given a sticker, some kind of little kid sticker that goes on your rocket. And that gets you to the RSO table and out on the range. Occasionally we'll have provisional, like your thrust to weight ratio is not quite right. We want you to fly when there's not more than a 5-mile-an-hour wind or something. We do want you to fly, but we do want it to be a nice, safe event. Hopefully this will spark some questions, and you can watch and participate in the online review for Spaceport. So, thank you.